Assalamualaikum and good day to everyone. We are from Group 6. We'll present about our experiment that we have done last week, which is Experiment 5 Bending Moment. So, first and foremost, I will introduce our team members for Group 6, which is consists of me, myself, which is Raihan, and then we have Adlan, Nakai Ali, and also Faizal. So, for the introduction, bending moment is a measurement of a force when it is applied at a given distance away from a material, causing the bending effect to happen to the material. Moment is a rotational force that occurs when a force is applied perpendicular to a point at a certain distance away from the point. To calculate moment, we have to multiply distance with the perpendicular force at a point. So the measurement of bending moment is essential in designing and analyzing the materials that needed to be used to produce a quality engineering structure such as buildings, factories, house areas, and also bridge. Next, we will proceed with the objective and scope of this experiment. The objective of this experiment is to measure the bending moment of material when subjected to different loads at different distance. While the scope of this experiment was being conducted with loads ranging from 5 Newton to 50 Newton and the distance between P1 and P2 and also the distance between P2 and P3 varies according to the section of the experiments conducted.
For the theory, a bending moment is the reaction that occurs in a structural element because of an external force of a moment is applied to the element causing it to bend. When a force total is applied to a body, it might result in three internal effects, which are shear, bending, and torsion. Figure 1 shows a simply supported beam. When a load is applied on the beam, it will cause an internal effect called bending. If we cut a cross section of the beam, we will get two parts, section A and section B. In between this section, there will be a shear force acting, QX. Vertical and moment equilibrium are achieved since there are no horizontal force acting along the beam. On the left-hand side, figure 2 shows the shearing force acting between the section. Shear force moving upward on the left side of the section and then downward on the right side of the section will be considered as positive shearing force. On the right-hand side, figure 3 shows the equilibrium of the moment. The downward arrow indicates that the moment of this beam is negative. To eliminate the shearing force, we can calculate by using the formula shown below. Next, we will move on to safety measure. All students should wear a lab coat and proper shoes before conducting any experiment. Before usage, all equipment should be thoroughly inspected to verify its safety and the load should be handled with care. To avoid error, keep your eyes perpendicular to the balance reading. Conduct the experiment carefully to prevent any error or injury. Next is error and precaution. To avoid parallax error, the observer must keep his or her eye level perpendicular to the scale of the measuring device at all times. It is possible to collect multiple sets of reading in order to acquire an average reading. For the human error, the experiment was not correctly set up, since the load hanger may shift slightly when the load are changed. We must confirm that the hanger and load are properly placed.
Table 1 shows the data that we got during our experiment in part 1. So in part 1, we set the distance between point A and P1 as 100 mm, while P2 and P1 is 150 mm, and lastly P3 and P2 is 300 mm. We also use four different loads, which are 0 Newton, 5 Newton, 10 Newton, and 15 Newton. Thus, the data that we collected for P1, P2, and P3 is as shown as in table 1. The formula for net force is the new balance reading minus the initial reading. Using those data, we can get the bending moment and the theoretical value of P1, P2, and P3. Next, in part 2, we only decrease the distance between P3 and P2 to 150 mm. As for the loads, we only use 0, 5, and 10 Newton. Table 2 shows the data that we collected when running the experiment. In the last part, which is part 3, we increase the distance between P3 and P2 to 200 mm and the loads we use are 0 Newton, 2 Newton, 5 Newton, 10 Newton, and 12 Newton. The data that we got is as shown as in table 3. As for the bending moment and the theoretical values, I will explain on how do we calculate in the next slide. So this is the calculation for part 1. As for this example, we take P1 equal to 5 Newton, and then we will do the summation of force in y direction and get the first equation, which is Ra plus Rb equals to 5. Then we will do the summation of moment in point B to get the value of Ra. Using the value of Ra, we can insert it in the first equation to get the value of Rb. As for the theoretical value, we will do the summation of moment in point C by inserting the value of Ra and P1. As for the bending moment, which using the data we get from the experiment, we just insert the net force and the distance, which is 150 mm. While in part 2, we decrease the distance between P3 and P2 to 150 mm. As for the example, we use P2 equal to 5 Newton, and then we will do the summation of Fy equal to 0 and get the first equation Ra plus Rb equal to 5. And then we will do the summation of moment in point B and get the value of Ra. We then substitute the value of Ra in equation 1 to get the value of Rb. As for the theoretical value, we just do the summation of moment at point C by inserting the value of Ra and P2. And for the bending moment, which is the data that we got from the experiment, we just do the same, which is the summation of moment at point C by multiplying the distance of 150 mm with 5 Newton net force. Lastly, in part 3, we increase the distance between P3 and P2 to 200 mm. For this example, we use P1 equal to 5 Newton and P3 equal to 12 Newton. Then we will do the summation of Fy in y direction is equal to 0 and get the first equation Ra plus Rb is equal to P1 plus P3. Then we will do the summation of moment at point B to get the value of Ra. Using the value of Ra, we can substitute it in equation 1 and get the value of Rb. For the theoretical value, we do the summation of moment at point C using the value of Ra, P1, and P3. As for the bending moment, which is the data that we got from the experiment, we just do the same, which is the summation of moment at point C by multiplying the distance, which is 150 millimeter, with 15 Newton net force. Next, we will move on to the discussions. In this table of the result of part 1, you can see that the theoretical value increased slightly in P1 when applying 5 Newton, 10 Newton, and 15 Newton, and at P2 when applying 5 Newton, 10 Newton, and 15 Newton, and lastly at P3 when applying 5 Newton. However, in P3, when we applied 10 Newton and 15 Newton, there is a significant increasement in the theoretical value compared to the experimental value. This may caused by a number of factors such as parallax error and the surrounding environment. The graph shows the experimental and theoretical value for part 1. So based on the graph, there are some information that we can conclude. Firstly, the theoretical bending moment value is directly proportional to the experimental bending moment value and the load. So the higher the experimental value, the higher the theoretical value. We can also conclude that as the load increases, the theoretical value will also increase. Okay, this is the experimental and theoretical value for part 2. So the graph for this experiment describes that the theoretical value is also directly proportional to the experimental value. And when we were conducting the experiment with P1 equal to P3 and equal to 10 Newton, with P2 equal to 5 Newton, we achieved the highest theoretical value, which is 4,797 Newton millimeter. As for the last part, which is part 3, at P1 equal to 5 Newton, P3 equal to 12 Newton, there is a height increasement from 2,250 Newton millimeter to 4,056 Newton millimeter. This may have to do with the distance between them. However, it is proven that the relationship between the load and the bending moment still can be applied in these three parts, which is the theoretical value is directly proportional to the experimental value and the load.
For the conclusion, this experiment was conducted to study the effect of different force at on different distance when applied to the beam. Bending moment can then be conducted by applying force to the beam. From the data, it can be seen that as the load increases, the shear force and the bending moment also increases. Next, the observation of the data yield that the theoretical data is higher than the experimental data. This is because of the random error that might happen during the experiment. Overall, it can be stated that the objective of the experiment have been fulfilled. Thank you.